Before we begin, take a moment to get comfortable. Let your arms go heavy, your breath slow. And as you listen, feel free to leave a comment sharing what time it is, where you are, and what city or village you're listening from. It's love to know. And if you'd like more quiet stories like this one, don't forget to subscribe so they gently appear when you need them most. Now, let's begin. You lie still tonight, nestled in your room, your body draped in quiet. The walls around you do not move. The bed doesn't pulse or tremble, but beneath your home, your city, your forests and rivers and highways, the earth is not still, it breathes. Not in the way your chest rises and falls with air, but in pressure and heat and silence that expands. A breath held not for seconds, but for centuries. The ground you walk on may feel eternal, but it is only the skin of something older, deeper, and much more patient. Beneath the grass and clay and stone, there are rivers of rock that flow slower than thought. There are chambers of magma sleeping like molten lungs. And in certain places on Earth, those sleeping lungs have the power to change everything. Not all volcanoes wake often. Some erupt with regularities small size of lava, bursts of steam, a cough of ash into the sky. But there is another kind, a rarer kind that waits not decades, but millennia, that stores its breath, holds it, deepens it till the earth itself must exhale. These are supervolcanoes, but don't picture fire and doom. Don't imagine a beast clawing its way from the deep. A supervolcano is not a villain in a fable. It's a whisper in the bedrock, a quiet swelling beneath the crust. It grows not in rage, but in waiting. Tonight, we begin beneath your feet, far below, past the worms and roots and rock, down where the planet is warmer, denser, darker. There, heat moves with the grace of ink in still water. A place without sound, where the Earth's story unfolds, not in pages, but in pressure. Volcanoes come in many forms. The ones we usually picture are steep cones, dramatic peaks with lava trickling down. But the largest of them, the most powerful of them, do not rise, they sink. A supervolcano hides its strength in a caldera, a vast collapsed bowl where the land has given way to something beneath it. These calderas are ancient wounds, not raw or open, but healed over, covered with forests, lakes, flowers. Life flourishes above them. People picnic, camp, build roads, take photos. Few realize what lies below. Yellowstone is one of them, but we won't go there just yet. Let's begin with the idea itself. What does it mean for the Earth to be alive, not in metaphor, but in movement? The Earth's crust is a mosaic of giant plates floating on a sea of softer rock. They drift ever so slowly. When they grind together, mountains rise. When they pull apart, oceans widen, and in the cracks between them, magma finds its path. Most of the time, that magma stays underground. It pools in quiet chambers, pressed by weight, held in check by rock. It is not angry. It is not impatient. It simply gathers and gathers you. Could live your entire life above one of these sleeping places and never know. Birds would sing. Rivers would run clear. The seasons would turn like clockwork. But down below, something ancient would be breathing slowly, in and out, waiting. How does a supervolcano form? It begins not with a bang, but with layers. Rock melts into magma. Magma rises, but cannot escape. It presses against the roof of its chamber. That roof thickens, hardens, but also strains. For tens of thousands of years, pressure builds, and still nothing happens, until one day, something shifts. A weakness appears, a crack, door, just barely ajar, and then, like breath released after an age, it exhales. But that is not tonight's concern. Tonight, we sit in the stillness before the breath. Think of the magma chamber as a lake not of water, but of glowing, molten stone. Beneath the Earth's crust, these chambers can stretch for miles in every direction. Imagine standing at the edge of such a lake. If it were exposed, you would see waves of orange and red, rippling like honey over coals. It would hiss, it would shimmer, but no such sight exists for our eyes. This lake lives beneath miles of solid rock, unseen, yet it waits. These chambers do not form overnight. Some took hundreds of thousands of years to reach their current size. Like a pot simmering on a very slow flame, the Earth cooks its own future. And what does the Earth feel as this heat builds? It does not feel like emotion. It is a feeling in structure and pressure. Imagine bending a thick metal rod slowly over centuries. You would never hear it creak, but one day it would snap. Now, think of the land above such a magma chamber. It rises ever so slightly, lifts and shifts like bread dough rising under a cloth. The changes are so subtle that human eyes cannot detect them unless they measure with great care. And scientists do, with satellite radar, GPS, and instruments buried in the earth. They watch, they listen. They tracked tiny tremors, small bulges, gas emissions. They are not predicting catastrophe. They are simply paying attention to breath. Supervolcanoes are rare. In the past 2 million years, only a handful have erupted. The Earth is not careless with these events, spaces them out, spaces with deep patience. It gives life a chance to grow again, but still, they are real. When one erupted long ago in what is now Indonesia called the Toba eruption, it nearly changed the course of human history. Some scientists believe the ash cloud dimmed the sky so thoroughly that global temperatures dropped, and much of the Earth entered a volcanic winter. Crops failed, populations shrank, the world paused. Yet it did not end. Life adjusted, regrew, relearned. That is the rhythm of the Earth. Expansion, pause, renewal. Beneath your feet, in places like Yellowstone, like Long Valley in California, like Taupo in New Zealand, this rhythm continues. And above it, we build cities, we plant fields, we soak in hot springs and take photos of geysers. We call it wilderness, or beauty, or tourism, but the land remembers, the heat remembers, and it is not angry, it is not restless, it is simply alive. You may be wondering, will it happen again? The answer is yes. But not tonight, not tomorrow, perhaps not for tens of thousands of years, or perhaps sooner. The Earth does not check calendars, it checks only pressure. And you live in the in-between. You are one of many generations who have danced atop a sleeping giant unknowingly. The ground beneath you holds secrets, yes, but not threats. It asks for reverence, not fear. When you walk in the mountains, when you feel warmth rising from a vent, when you see colors swirling in the water of a geyser, know that these are breaths. They are signs of life beneath the soil, and they have always been there. Tonight, as you drift toward sleep, think of the ground, not as solid stone, but as something breathing slowly beneath you. Think of the deep time of Earth, where 1,000 years is just one inhalation. And as you rest, let your body join that rhythm. Let your breath slow to match the Earth's. Not all power is loud. Not all danger is urgent. Some things are simply patient, and waiting is their way of being. And if the Earth can wait for millennia, perhaps we too can wait and listen to the warmth rising quietly from below. From below. You've seen images of volcanoes before, mountains with smoke spiraling from their peaks, rivers of lava glowing red against the night. You've heard stories, Pompeii frozen in ash, fiery fountains in Hawaii, the sudden roar of Mount St. Helens. But these are only pieces of a larger picture. Most volcanoes are modest storytellers. They speak, often in smaller bursts. They crack, hiss, ooze, and rumble. Their eruptions may be dangerous, yes, but they are also familiar. It's predictable, even. They erupt, they rest, they erupt again. People adapt. They build cities in the shadow of fire, okay, and learn to read the moods of the mountain. But a supervolcano tells a different story. It doesn't shout. It waits. It gathers its strength in silence. And when it finally speaks, it doesn't just reshape. A mountainette rewrites a continent. The word supervolcano isn't a poetic exaggeration. It's a scientific category, a classification based on size, scale, and consequence. So tonight, as your eyes close and your breath slows, let's walk slowly through this idea. What makes a volcano super? It begins with a number. When scientists describe an eruption, they use something called the Volcanic Explosivity Index, or VEI. It's a scale, much like the Richter scale for earthquakes. Each step up means not just more force, but exponentially more. A VEI3 eruption might be loud and dramatic, okay? But a VEI7 is something else entirely. To earn the name supervolcano, an eruption must reach VEI8. That number might sound abstract, but think of it this way. A VEI8 eruption releases more than 1,000 cubic kilometers of volcanic material. That's enough ash, pumice, and rock to bury entire regions under meters of debris. Enough to dim the sun, enough to shift climates, enough to echo through history. But even this definition is clinical and measured. This is something important. The feel of a supervolcano is different. Imagine the ground lifting not in feet, but in miles. It's the air thickening with fine, choking ash. Daylight turning to dusk in places hundreds of miles from the eruption site. Crops withering beneath a gray sky. Airports silent. Rivers changed. Lives paused. And then imagine all of this, not as a flash, but as a long unfolding. Don't necessarily explode upward in a single burst. They can erupt in waves, phases, sequences of outpouring. The sky becomes an evolving canvas of ash and sulfur. The earth holds its breath for months. But here's the strange part. Supervolcanoes rarely leave behind towering peaks. In fact, many don't look like mountains at all. Hairy eruptions are so powerful that the land above collapses inward. The result is a caldera-wide, sunken bowl where the ground has given way. You might walk across a caldera and not even know it. Trees grow. There, lakes form, roads wind through. Yellowstone, for instance, isn't a mountain, it's a massive caldera over 30 miles wide. That's part of what makes supervolcanoes so quietly unsettling. They don't look like threats. They look like peace. They are forests, meadows, clearings, full of life. But beneath that peace, the earth is holding history and pressure. Now, let's go deeper. What causes such an enormous eruption? The answer lies in magma composition, the mixture of molten rock and gas beneath the surface. Some magmas are fluid and runny, like those in Hawaii. They flow freely, oozing lava in predictable streams. But the magma beneath supervolcanoes is thicker, more viscous. It traps gases like steam in a sealed kettle dot as pressure builds. So does the potential for something explosive. It's like inflating a balloon with no idea of its limit. Eventually, the crust can no longer contain the growing force dot, and when it breaks, the result is not just eruption, it's transformation. The ground cracks, lips, and then collapses. The landscape becomes unfamiliar. A bowl replaces a hill. A lake forms where a forest stood. And even after the eruption ends, the echoes linger for centuries. Ash doesn't disappear. It settles. In 1815, a VEI7 eruption in Indonesia Mount Tambaru spewed enough ash to cause the year without a summer. Crops failed in Europe and North America. Snow fell in June. People starved. And yet Tambora was not ASUPERVOLCANO. What happened there was immense. What a supervolcano could do would be larger still. And yet let's pause, because this isn't a story of fear. The Earth is not cruel, it is complex. Supervolcanoes are not villains, they are ancient expressions of geological breath. They remind us that time is deep and power can be patient. In fact, most of what we know about these eruptions comes not from panic, but from ash layers, from soil studies, from chemical signatures in ice cores, thousands of miles from the source. Scientists read the Earth's past like tree rings. Each layer tells a story. How hot the world was, how light the sky became, how quickly species adapted. This is how we know that the last supervolcano eruption at Yellowstone was about 640,000 years ago. The one before that, 1.3 million years ago. That rhythm might seem comforting, and it is, in a way, because while supervolcanoes are real, they are not constant. They are events of deep time. Human civilizations, with all their wars and wonders, are brief flickers compared to the intervals between such eruptions. So, you may wonder, why do we talk about them at all? Because the Earth is not a museum. T is a living system, and part of honoring its rhythms is listening not with fear, but with awareness. Scientists study supervolcanoes not to alarm, but to understand. They map the heat beneath the crust. They monitor the gases rising through vents. They measure the tilt of the land. These are the quiet ways we listen to the Earth's breath. We prepare, not because we expect, but because we respect. You are part of that listening. By simply knowing what lies beneath, you become part of the awareness, the calm, the readiness that doesn't disturb the peace, but holds space for it. And there's something else. Supervolcanoes have given, not just taken, the nutrients in volcanic ash and rich soil. Some of the world's most fertile farmland lies atop ancient eruptions, hot springs, geysers, and thermal features. Many cherished and healing exist because of volcanic heat. Even life itself may owe something to the dynamic churning of the Earth. The warmth, the minerals, the energies these have always shaped the possibility of life. So tonight, let this be your lullaby. Not all power is noisy. Some sleeps beneath your step, beneath your story, And it asks, not for fear, but for noticing. Because the next time you feel the Earth is solid, remember, it is only briefly so. And beneath your bed, beneath your land, beneath your breath, something vast is always waiting. And when it dreams again, the sky may darken, but even then, the Earth will turn, and morning will come. You may have visited Yellowstone, or perhaps you've only seen it in photographs, winding road through pine forests. A sky wide and blue, a bear glimpsed in the distance. Maybe you've watched Old Faithful erupt in its scheduled dance, water leaping toward the sky in a plume of mist and wonder. Maybe you've stood on a boardwalk over steaming pools, the air thick with the smell of sulfur, minerals staining the earth in otherworldly colors, turquoise, rust red, milky white dot. It feels like a magical place, a place where the earth speaks in warm breath and strange colors. But beneath that, beneath every tree, every bison, every cheerful family in hiking boots lies something older and quieter. Yellowstone is ASUPERVOLCANO. Not a peak, not a single cone, but a caldera, an ancient, sunken wound in the Earth's crust, stretching more than 30 miles across. You don't see it from above, not easily. The forests and lakes and trails hide its shape, but the land is marked by the memory of violence. It is peaceful now, quiet, but only because it is resting, and that rest is part of what makes it extraordinary. To stand in Yellowstone is to stand inside a volcano so large that it swallows you whole. You are not beside its war within it. Every bubbling spring, every rising steam vent, Every shifting geyser is a whisper from deep below, a reminder that the earth is not finished. The ground beneath Yellowstone is warm, not just from the sun, but from heat rising through fractured rock. Magma lies closer, here, close enough to warm underground water into steam, to push pressure upward until it breaks through and bursts. This heat is not uniform. It moves in pockets and pulses like breath. Geologists measure its rise in strange ways. Changes in ground tilt, new cracks in rock, changes in the chemistry of water, sudden animal migrations. Yellowstone exhales gently most of the time. Once many times it roared. The last major eruption happened about 640,000 years ago. You have to imagine it slowly, without panic. Imagine the earth swelling, ground lifting, gases building, magma chambers stretching, till finally, without exact timing, without a warning, we would recognize today the land fractured, collapsed, and released more than 1,000 cubic kilometers of ash and rock into the sky. That eruption reshaped the continent. Ash rained down as far as the Gulf of Mexico. The skies darkened, forests burned, temperatures dropped. The caldera, the vast depression we call Yellowstone, today formed from the collapse of emptied magma chambers. The land above had nothing to hold it up, and then silence. Not complete silence, of course. Yellowstone has continued to breathe. There have been smaller eruptions, lava flows, steam blasts, earthquakes that shake the silence loose. In the 1980s, new ground deformation caused parts of the park to rise, then fall by several feet. It wasn't a sign of doom, just a reminder, this place is alive. Yellowstone's geothermal features, geysers, mud pots, hot springs are the visible signs of an invisible heart. They are the result of water interacting with heat, minerals, pressure, and because they are so dynamic, they are constantly changing. Geysers stop erupting. New ones appear. Pools grow, shift, or drain overnight. It is a landscape in motion, and you are part of it. When you walk across Yellowstone, you are walking across a living map. Every step brings you closer to something ancient. Every steam vent is a breath from the past. Every sulfur-scented gust is a whisper from the mantle below. Yet, in its quietness, Yellowstone invites wonder, not fear, because to visit Yellowstone is to feel how small you are and how deeply connected. It is to stand atop a wound that healed in moss and meadow. It is to recognize that something immense happened here, and life came back. Anyway, bison graze near hot springs, elk cross steaming creeks, ravens fly through sulfur-scented mist. Life does not flee this place. It thrives in it. In fact, some of Yellowstone's microbial life, teeny bacteria living in hot springs, have helped scientists understand extremophiles, organisms that survive in harsh, alien environments. Life here has adapted, not in spite of the heat, but because of it. And that is Yellowstone's quiet lesson. Destruction and creation are not opposites, they are partners. The eruption that formed this caldera also created the conditions for a rich ecosystem. It shaped the rivers, fed the soil, formed the lakes, gave birth to the springs and geysers that draw millions of people each year. You don't need to stand in fear of Yellowstone, but you do need to stand in attention, because while supervolcanoes don't work on human timelines, they do work on patterns. Scientists now use an array of tools to monitor Yellowstone GPS devices, satellite imaging, underground sensors, SEISOOGRAPHS. They watch for signs, not because they expect an eruption, but because they want to understand. For instance, the ground has been slowly rising in some parts of the park. That doesn't mean an eruption is coming. The earth swells and shifts all the time. But those movements are like whispers in a vast cathedral. If you listen carefully, you learn the song of the stone. Yellowstone is also unique because of its visibility. It's protected, preserved, loved. That love is part of its safety because we are watching it. And through that watching, we learn not just about this one place, but about the planet itself. Yellowstone is a window. It teaches us about magma chambers, about the fragile dance between pressure and silence, about what happens when the Earth stretches too far. It gives us a living laboratory to study geothermal life, volcanic rhythms, and long-term geological cycles. And still, despite everything we know, despite all the science and study, despite every satellite and sensor and seismic chart, we cannot say when if ever it will erupt again. That uncertainty is not a threat. It is an invitation to live with the Earth, not apart from it, to pay attention without panic, to see beauty, even in instability. So as you lie down tonight, close your eyes and imagine Yellowstone, not as a threat, but as a sleeping artist, one who once painted the sky in ash, and now whispers through geysers, pools, and steam. Imagine walking there again, the air cool, the sky wide, the earth beneath you, warm in its silence. You are part of that silence, and the land is listening back. What we call peace is not the absence of eruption, but the harmony of knowing, listening, and letting the earth be old and just beneath your quiet path. The magma chamber waits ancient, slow, and vast, its breath warming the roots of trees you cannot see. You wake in the morning and step outside. Its ground beneath your feet feels solid, still, unmoving. It holds you without question, as if it has always been there and always will be. But beneath that stillness, something stirs slowly, silently, far below. This chapter is about listening to what cannot be heard, seeing what cannot be seen. It's about tracing the warmth of a sleeping world, okay? And trying to understand how to watch something that lies hidden deep beneath the surface. Because you cannot see a supervolcano with your eyes alone. There are no peaks announcing its presence, no smoke curling from a singular cone. Yellowstone, like many supervolcanoes, is a caldera, vast depression, not a mountain. It's a bowl, not a spire. And while geysers and hot springs give hints of activity, the true heart of Yellowstone eats magma, its pressure, its hits, far below. So how do you map a giant that sleeps in silence? You start by listening to its breath. Geologists and volcanologists have created a symphony of instruments designed not to wake the earth, but to quietly observe it. Seismometers, satellite radar, GPS markers, thermal sensors, gas analyzers. These devices are placed across the caldera, on ridges and in valleys, tucked beside steaming vents, hidden in forests, and, together, they form a kind of sensory net away to catch the Earth's whispers in motion. Every tremor is recorded, every rise and fall in the land is measured, every shift in gas, every flutter of heat, every sound that echoes from deep beneath the crust is logged, mapped, and compared, because Yellowstone, and places like it, are not truly still. The ground moves in subtle waves, like a body breathing in its sleep. Over months and years, the land lifts and settles sometimes, inches at a time. And while those shifts are imperceptible to the hikers walking over them, satellites above the Earth can see them. Instruments called NSAR, interferometric synthetic aperture radar, can measure millimeters of vertical change from space to a scientist. The Earth becomes a moving canvas. One year, the caldera may bulge. Another year, it may sink. These movements are not random. They are signs of magma shifting below, of pressure building or releasing. They are the slow conversation between the planet's crust and its molten core. In the 2000s, geologists noticed something curious. Parts of the Yellowstone caldera were rising more quickly than before per 2-3 inches a year. Then, around 2010, they slowed again. Nothing erupted. No dramatic events followed, but it was a reminder. The magma chamber was active. still stirring in its sleep. Beneath Yellowstone, there are actually two major magma reservoirs. The upper one is closer to the surface, while the deeper one lies closer to the mantle. These chambers are not solid lava. They are mixtures of molten rock, gases, and crystals, shifting and flowing over time. When the balance between pressure and containment changes, the Earth responds. But pressure doesn't always mean eruption. Sometimes the heat simply migrates. Magma shifts laterally, moving from one part of the chamber to another. Sometimes it cools, crystallizing into rock over centuries. Sometimes it heats groundwater, creating new geysers or altering existing ones. And sometimes it remains in place quiet, but present. Scientists also study gas emissions. In volcanic regions, carbon dioxide and sulfur dioxide are common indicators of underground activity. At Yellowstone, researchers measured the gases escaping from fumaroles and hot springs. Changes in the ratio of these gases, especially increases in carbon dioxide, can suggest movement of magma closer to the surface. Yet, even here, the Earth speaks softly. Gas levels fluctuate with weather, seasons, and surface changes. One must look not for dramatic spikes, but for subtle patterns over time. In 2003, a rare hydrothermal explosion occurred in Yellowstone's Norris Geyser Basin. A pool exploded, ejecting boiling water and rock. No one was hurt, no eruption followed, but it was a reminder that even surface features can surprise. The explosion carved a crater 20 feet wide, and just like that, the land shifted again. That's the nature of volcanic study. You wait, you measure, you watch, and still, there is mystery. Because even with all our tools, the heat below remains elusive. Thermal imaging has revealed warmer areas beneath the park zones where heat flows more quickly to the surface. These hotspots align with known faults and vents, but the exact shape of the magma, its temperature, its thickness, all of it is estimated, modeled, never fully known. This uncertainty is not failure. It is the nature of deep earth science. The crust is thick. The sensors are indirect. And magma does not glow like a candle in the dark. It whispers through density changes, heat signatures, gas ratios. Still, we try to build a picture. Imagine this. You are floating above Yellowstone, not in a plane, but in a satellite below you. The trees form a dense green sea. Lakes shimmer. Roads wind like threads. But through specialized radar, you see the land moving, rising here, sinking there. You switch to thermal imaging. Brightness appears near Norris, near the caldera's edge. Geysers flicker like tiny lanterns. Heat seeps from deep below. You switch to seismic readings. A map of tremors appears, dots marking earthquakes over the past week. Most are small too, faint to be felt. But they form clusters, swarms, patterns that hint at motion beneath that. Then you zoom below, through the crust, into the chamber, first the upper, then the lower. You see the magma not as a red pool, but as a mixture of heat, pressure, and potential. It flows slowly, cools at the edges. It pulses, waiting, changing. This is the map scientists work from, a map of ghosts and shadows. But it is still a map, and every year it gets clearer. New studies have used supercomputers to model magma behavior. Others use sound waves called seismic tomography to create 3D images of underground structures, like a CAT scan of the planet. And still others drill cores, take gas samples, or study the chemistry of ancient ash layers. Because the best way to understand the next eruption is to understand the last. What caused the massive Yellowstone eruption 640,000 years ago? What preceded it? What did the land do in the months and years before? The more we know, the more we can listen. And that is the quiet heart of volcano monitoring. It is not about panic. is not about predicting doom. It is about learning the language of the earth and respecting it. Because the magma does not hate us. It is not waiting to erupt out of anger. It simply is. It moves according to laws older than memory. And if we are wise, we learn to move with it. Today, Yellowstone is watched by the Yellowstone Volcano Observatory, a partnership of the U.S. Geological Survey, National Park Service, and universities. Their work is not dramatic. There are no red warning lights. Most days, the reports are calm, stillness, normal seismic activity, minor changes. But behind every line in those reports is a deep well of data, years of listening, measuring, interpreting. And behind that data is a truth. The earth is warm beneath us, and that warmth has stories to tell. So as you fall asleep tonight, know this. Even now, in the darkness, the satellites are passing overhead. The ground is breathing softly. The scientists are listening, not to predict the end, but to understand the beauty of what lies below. Some truths can only be heard when you are quiet, and some maps are drawn with silence. You walk across a meadow, unaware that miles beneath your feet, a chamber is growing. Not loudly, not quickly, but patiently. A place where heat and pressure gather in the dark. A hidden pocket of possibility, slowly preparing for a story it may never tell. This is the lava chamber, the silent heart of a volcano. And when it comes to supervolcanoes, this heart is vast, wide as a city, deep as memory, and older than language. But what is a lava chamber, really? It's not a bubbling pool of red-hot magma, like in cartoons. It is not a perfect cavern with smooth walls and glowing light. It is something more complicated, more quiet. It is a zone deep in the Earth's crust where molten rock collects intermixed with crystals, gases, and semi-solid material. Some parts may be fully molten, others may be a soft sludge. Together, they form a dynamic, shifting body of energy, warmth, and weight. Imagine a slow breath held inside stone. That is what a lava chamber feels like. At Yellowstone, this chamber is enormous. The upper chamber, shallowest, stretches roughly 30 miles long and 10 miles wide. Below it, the deeper chamber may reach 300 miles across. But even those numbers are estimates built from seismic echoes and computer models. You cannot drill that deep. You cannot look directly. You can only listen and interpret. Inside these chambers, pressure builds. Not like a balloon filling with air, but like honey thickening in a jar left too long in the sun. The magma shifts. It expands. Crystals grow, melt, regrow. Gases become trapped carbon dioxide, sulfur dioxide, water vapor. And as these gases accumulate, they press upward, slowly, imperceptibly, relentlessly. If the overlying rock is strong, it holds. But if the chamber grows to full F, the pressure becomes too great, or the roof thins, something changes. The earth does not like imbalance, so it adjusts. This adjustment may take the form of an earthquake, a fissure, a slow leak of steam, or, rarely, an eruption. And in the case of a supervolcano, that eruption is not a single cone bursting. It is an entire region collapsing inward as the pressure releases upward. The chamber empties. The ground falls. A caldera is born. But let's return to the stillness before that moment, because for centuries, sometimes for tens of thousands of years, lava chamber can wait. In that time, the chamber becomes a kind of archive. It records the history of its own warmth. Layers of magma cool and solidify along the walls. Crystals form, catching the chemistry of each generation of melt. Geologists sometimes find chunks of these solidified rocks in later eruptions, synoliths, they're called. Foreign stones carried upward from the depths, like fossils from the inner earth. By studying these pieces, scientists read the past. They learn how many times the chamber filled, how many times it emptied, what kind of gases were present, how hot it became, how long it waited. It is like reading tree rings, but on fire and pressure. Not one of the most extraordinary findings at Yellowstone is just how long the magma has been active. Evidence suggests that the region has hosted volcanic activity for over 16 million years. The hotspot that feeds it has moved slowly northeast, leaving behind a trail of ancient calderas across southern Idaho. The scars of past eruptions, now weathered into plains and plateaus. These are the ancient chambers, long since cooled, long since buried, but their stories are still written in stone. In the Snake River Plain, researchers study old deposits of ash and lava. Some flows are 2 miles thick. Others stretch for dozens of miles. Each layer speaks of an eruption, some large, some small, some explosive, some flowing like syrup. Together, they form a geological diary of deep time, and through this diary, we see a pattern. Every few 100,000 years, the Yellowstone region experiences a massive eruption. The last three occurred roughly 2.1 million, 1.3 million, and 640,000 years ago. That doesn't mean we are due. The Earth doesn't follow a clock, okay, but it does suggest a rhythm, a breath pattern, if you will. In between these great eruptions, smaller events still occur. Lava flows, hydrothermal explosions, earthquake swarms. These are the surface hints of deeper processes, the exhalations between deeper silences, the chambers beneath. Those stone are not isolated. They connect two faults, two fractures, two layers of brittle rock. These connections allow heat and pressure to migrate. Sometimes magma moves sideways instead of up. Sometimes it stalls, hardens, waits. Other times it pushes upward, melts surrounding rock, and creeps closer to the surface. But it's not only Yellowstone. The Long Valley caldera in California has its own chamber. So does Valle's caldera in New Mexico, in Taupo in New Zealand, in Toba in Indonesia. Each one is different in size, shape, and temperament. Some are quiet. Others, like Taupo, are more restless, occasionally sending out plumes of gas or small bursts of ashdod. These chambers are not threats. They are processes, parts of a living earth. And like all living systems, they follow cycles of growth, rest, change. It's humbling to realize how little we can see of them. The deepest parts of the chamber, those near the mantle, are beyond reach. We only infer their shape through seismic waves, which bend and bounce as they pass through. Slower waves often mean hotter, more fluid material. Faster waves suggest colder, solid rock. By comparing thousands of seismic readings from small earthquakes, scientists built images blurry, imperfect, but telling. These images show a world of complexity, magma pockets that rise and sink, fingers of melt reaching toward the surface, chambers within chambers, like nesting dolls of heat. And always the slow movement of Earth's breath beneath. Sometimes the pressure in a chamber rises dramatically. In 2014, researchers discovered a sudden surge in uplift near Norris Geyser Basin, up to 5 inches in a single year. It wasn't an eruption, but it was a message. The chamber was shifting. Gases were moving. The Earth was adjusting. And then it stopped. The uplift slowed. The breath exhaled. Not all movements lead to disaster. Most lead to nothing, or to subtle rearrangements. The chamber finds a new balance. The crust settles. The story continues. In the deepest parts of the chamber, temperatures may exceed 400 degrees Fahrenheit, about 760 degrees Celsius. But even here, the magma is not entirely molten. Much of it is partially solid, like toothpaste or thick glass. This mixture flows slowly under immense pressure. And as it flows, it feeds the surface in subtle ways. It warms groundwater, creating hot springs. It ships rock, causing earthquakes. Okay? It emits gases that rise through cracks. And all of these signals are watched by humans above. Curious and careful, because every magma chamber is both a memory and a potential. It remembers past eruptions, its layers, its composition, its temperature gradients, and it holds the possibility of future change. Not tomorrow, not next year, but someday. And that someday is not a threat to it, is a natural part of Earth's cycle. You were born on a planet that breathes magma, a planet with a hot core and a restless crust, a world that builds mountains and then melts them down again. So tonight, as you lie in bed, know this: beneath the cool soil of the world, there are chambers of quiet fire. They are not monsters. They are not waiting to harm. They are simply waiting, as they always have. And above them, we walk, wonder, we listen, and perhaps, if we are still enough, we begin to hear the rhythm beneath our lives. That slow, deep, molten rhythm, up, leads us to the next quiet question. Because if these ancient chambers remember, what did they remember about the last time the world changed? The last time Yellowstone spoke with force, no one was there to hear it. No cities, no books, no satellites or voices to record the sound. But the land remembers. The rivers remember. And if you read the soil like a story, the story tells itself one. Of fire, of silence broken, of a sky that dimmed, of life that wandered on. That eruption happened about 640,000 years ago, a number so large it hardly feels real. But this wasn't the distant past of dinosaurs or trilobites. This was the Ice Age. Mammoths roamed the land, saber-toothed cats, early ancestors of the bisons. The earth was already home to life that breathed cold air and knew how to survive long winters. And then came the ash. Before the eruption, Yellowstone's magma chamber had swelled. Pressure had grown in the upper and lower reservoirs, fed by the heat rising from the mantle plume below. The crust bulged. Gases built up: carbon dioxide, sulfur dioxide, steam. Tension found no escape, and then the chamber gave way, but not in a single cinematic burst. It's more likely the eruption began with fractious long cracks in the ground near what is now the Yellowstone River. Through these cracks, sweeted gases and magma rushed upward, exploding into the sky with unimaginable force. Ash columns rose higher than Mount Everest. Some scientists estimate as high as 30 miles. Imagine looking up and seeing not clouds, but pillars of hot dust reaching into space, blackening the sun, glowing at their base. Lightning danced through them, volcanic lightning caused by particles crashing together and building static charge. Then came the pyroclastic flows. These were not just flows of lava. They were avalanches of gas, ash, and pulverized rock harder than any oven, faster than any hurricane. They poured across the land, consuming everything in their path at hundreds of miles per hour. Forests disappeared. Rivers boiled. The very ground was remade. The total area buried by these flows stretched across thousands of square miles. Today, much of this is preserved as the lava creek tufa, thick layer of volcanic rock that marks the signature of that great eruption. But the ash did not stop there. It rode the wind across what is now the Midwest. The plains, even as far as the Gulf Coast, fine gray particles settled like snowfall. Some regions received several inches of ash. Others saw a light dusting, but everywhere the world dimmed. The sun grew fainter. The air tasted dry, metallic, strange. For animals, this was disorientation. For plants, it was suffocation. Ash is more than dust. It clogs lungs, scratches eyes, poisons water, and buries crops. It insulates heat into the soil, cooking roots. And when wet, it turns to cement, collapsing roofs and choking streams. Across the continent, the ecosystem changed. Not forever, but enough. It was a volcanic winter. Sulfur dioxide released into the stratosphere, combined with water vapor to form aerosol steamy particles that reflect sunlight. These aerosols circled the globe, cooling the Earth's surface. Temperatures may have dropped several degrees worldwide. In a fragile world already deep in the rhythms of glacial advance and retreat, even a few degrees meant change. We don't know exactly how long that volcanic winter lasted. Perhaps years, perhaps longer. Eventually, the ash settled, the aerosols dispersed, and life resumed. How do we know all of this? Not from written records, but from the ground itself. Layers of ash preserved in lake beds and ocean cores tell the story. The Lava Creek ash is found in 20 U.S. states and parts of Canada and Mexico. By analyzing its chemical signature, scientists can match distant samples to their source, trees, to preserve the moment. Some petrified forests in the region are buried under this ash layer. Their rings stop abruptly, a sudden death, and then new life growing above them. But perhaps most haunting are the animal fossils at sites like Ashfall fossil beds in Nebraska, believed to be from a different, earlier eruption. Entire herds of rhinoceros, camels, and horses lie preserved in place, having suffocated under falling ash. Though not from the Yellowstone eruption, it reminds us what supervolcanic ash can do. And yet, the world did not end. It changed. It adapted. New ecosystems emerged. New paths opened for migration. The climate found balance again. When we talk about supervolcanoes, it's tempting to speak in terms of catastrophe. But Earth has always been shaped by such events, not as apocalypses, but as resets, challenges, pivots in the long narrative of time. Yellowstone has erupted 3 major times. The oldest was 2.1 million years ago, the Huckleberry Ridge eruption. It was the largest, releasing over 2,500 cubic kilometers of material. Then, 1.3 million years ago, the Mesa Falls eruption followed, smaller, but still massive by human standards. And finally, the Lava Creek eruptions 640,000 years ago, the one whose scars still shape the park today. Each eruption formed a caldera, a massive depression left behind after the magma chamber collapsed. But if you visit Yellowstone today, you won't see a crater. The land has healed over. Forests, rivers, geysers now fill the void. What once was destruction is now a sanctuary. Still, signs remain. Yellowstone Lake sits atop part of the caldera. Its shape is subtly distorted by ongoing uplift caused by pressure deep below. Hydrothermal features, like Old Faithful, are fueled by the heat that remains in the subsurface. Geysers, hot springs, mud pots, they are the breath of an earth still simmering. And the ground moves. In the 2000s, scientists noted rapid uplift in parts of the park up to 7 centimeters per year. Not a danger, necessarily, but a reminder that Yellowstone is not dormant. It is active, alive today. It is one of the most monitored volcanoes in the world. GPS stations track movement. Seismometers listen for quakes. Gas sensors measure emissions. Scientists from the U.S. Geological Survey and Yellowstone Volcano Observatory watch closely, not out of fear, but out of curiosity, caution, and care. And what do they find? That the system is stable. No immediate signs of eruption. No accumulating crises. But also, no stillness, because Earth is never still. It shifts in sleep, and in that slow shifting, it writes the next chapter. Will there be another eruption like Lava Creek? Eventually, though, in geological time, maybe thousands, even tens of thousands of years. Could it be tomorrow? The odds are extremely low. But the more important question is, how do we live with that knowledge? Not in fear, but in awareness, because the last time Yellowstone blew, the world did not end. It changed. It adjusted. and so did everything living on it. You are part of a species that has crossed fire and flood, ice and famine. One that watches the stars, listens to the earth, and builds models from rock. Tonight, you rest on that same earth, and beneath you, the memory of ash still lingers, not as a warning, but as a whisper from a world that keeps breathing, no matter how quiet it seems. And now, as you breathe in this quiet moment, the next question gently rises with the wind. If ash once blanketed a continent, where would it fall if it happened again? The wind doesn't know what it carries. It only knows how to move eastward, upward, sometimes downward, but always forward. And when a supervolcano speaks, the wind becomes its scribe. Not with fire, not with voice, but with ash. Volcanic ash is not like the soft ash in your fireplace. It is not the delicate remains of something burned. It is shards, tiny, sharp fragments of rock and glass, blasted into the sky and broken again by turbulence. It is born in violence, but settles in silence. And it travels far. From Yellowstone, the ash once rode the wind to places we now call Nebraska, Kansas, Iowa, Missouri, and even farther. Some researchers believe that trace amounts of ash from past eruptions reached as far as the East Coast. Imagine living 1,000 miles away, still brushing gray powder from your windowsill. Size of the ash cloud depends on the eruption's force and duration. In a supervolcano event, the column of ash can rise miles into the stratosphere, where winds move faster and more consistently. At that height, ash no longer belongs to a single place. It becomes part of the global sky, and as it falls, it changes. Everything. The first change is visibility. Ash darkens the day. It filters sunlight, turning blue skies a smudged gray. Even a thin layer in the atmosphere can reduce solar radiation by 10 to 15%. Shadows disappear. Colors flatten. It is not total darkness, but it is a dim world, soft-edged and strange. Then comes the weight. Even a few millimeters of ash can accumulate on cars, rooftops, and power lines. If it's dry, it blows. If it's wet, it clings like cement. In the worst-hit areas, roofs collapse, not from fire, but from ash piling up like snowfall with sharp teeth. The next effect is health. Ash enters the lungs. Its particles are small, enough to be inhaled deeply. They scratch the lining of the throat, irritate the eyes, clog the nose. For those with asthma, bronchitis, or heart conditions, it can be dangerous. Masks help, but only the right kind. Cloth won't stop the finest shards. Water becomes a question. Ash contaminates reservoirs, seeps into wells, turns clean water cloudy and corrosive. It carries chemicals like fluoride, which can leach into the body through drinking or washing. In agricultural areas, animals suffer too. Cattle inhale ash while grazing. Crops die under the gray layer. And yet, ash is not poison. It is mineral rich. In time, it feeds the soil. But time must pass first. When Mount Pinatubo erupted in 1991, in the Philippines, a much smaller eruption than what Yellowstone could produce, ash-blanketed regions hundreds of miles away, in areas with heavy rainfall. Lahars formed fast-moving rivers of ash and water that moved like concrete, sweeping away bridges and homes. These flows continued for years after the eruption, long after the volcano had gone silent. Now imagine ash falling across North America, across Montana, where pine forests whisper, across the Dakotas, where fields stretch like breathing blankets, across Chicago, New York, Atlanta city grids gone soft in layers of gray. Airports would shut down. Jet engines can't handle ash. It melts inside them, then hardens like glass. In 2010, a relatively modest eruption in Icelandic village gold-grounded European flights for nearly a week. That eruption was minor. Yellowstones would affect the globe. Solar panels would dim. Power plants might need to shut down. Roads would become slick. Emergency vehicles would need filters. And all of this, not because of lava, not because of fire, but because of the dust in the sky. And still, ash moves quietly. It's the silence that unsettles. No sirens, no explosions, just a steady settling, hour by hour, like time itself falling asleep. But there's beauty, strange as it seems. Ash layers are records. They mark time in the Earth's memory. In the Arctic cores of ancient ice hold thin gray lines that match eruptions from thousands of years ago. In lake beds across America, geologists dig through layers of sediment and find volcanic signatures preserved like pressed flowers. They know the age of the eruption, the chemistry of the ash, even its source. Some layers are less than a millimeter thick, but still carry the fingerprint of Yellowstone. In the future, the same might happen again. Ash would fall. It would cause hardship. But then it would settle. It would become part of the ground beneath our feet. And one day, someone somewhere would dig down, brush it gently away, and say, "This is when it happened." There is also the question of how much ash might fall and where. Scientists use computer models to simulate different eruption scenarios. One of the most well-known studies by the U.S. Geological Survey mapped possible ashfall across the United States in BHS, the event of a Yellowstone SUPEREREPTION, according to their conservative model. The zone closest to Yellowstone, parts of Wyoming, Montana, and Idaho, could receive several feet of ash. Structures would collapse. Life would stop. States farther out, Colorado, Utah, the Dakotas, Nebraska, could see inches of ash, enough to cause major infrastructure failure. Even the East Coast might see a thin coating, just enough to shut airports, muddy rivers, and make people pause before stepping outside. The map of this ashfall is oddly beautiful, gradient from dark to light, a visual lullaby in gray, okay? But each line represents challenge. Each contour, a layer of slow interruption. Still, it is not an apocalypse. People are resilient. Cities adapt. Power can be restored. Crops can be replanted. Ash can be swept. Even lungs healed in Iceland after volcanic eruptions. People return to their farms. They clean their roofs. They wait for the green to return beneath the gray dot. In Japan, ash is part of life in places near Sakurajima. Children wear helmets and masks to school. Cars have special wipers. Like it is not fear, it is familiarity. And so too, one day, could it be. In America, preparedness is the antidote to panic. Knowing what ash is, understanding how it moves, what it carries, what it means, not just scientifically, but emotionally, because ash is also a metaphor. It is the evidence of what was in the possibility of what comes next. Volcanoes, after all, do not choose where to erupt. They respond to pressures built over deep time. Pressures we cannot see, but can now measure, map, and whisper about in stories like this. You might wonder, how long would the ash linger? The heavier particles fall first, within hours or days. Okay, but the finest particles, those that reach the stratosphere, can circle the globe for months, even years. They reflect sunlight. They cool the earth. This is how a single eruption in one corner of the world can affect agriculture, rainfall, migration, economics, everywhere. But slowly, the atmosphere clears. Rain washes the air. Soil heals. Trees return. And in that healing, life reshapes itself around the memory. That's what ash is. Memory in physical form. A memory that dusts mountaintops, that sinks into rivers, that, when pressed into stone, becomes tougher rock made from fire and time. It's the silence after the sound, the soft weight that reminds you something powerful once passed through here, and now As you lie still, you can almost imagine it. The hush of falling ash, the world slowing, not ending, just pausing, not dying, just breathing differently. Because every supervolcano writes its story, not with flame, okay, but with the patient, drifting language of dust. And as you listen to the world settle, the next thought rises, slow and strange. What happens, asterisk, when that dust begins to change the weather? Imagine waking up to a summer morning where the light has changed, not gone, but subdued. The sky is a dull, veiled gray, like cotton stretched across a lamp. The sun is there, but weaker, its rays scattered. The shadows are soft, and the air feels still, not because the wind has stopped, but because something has stepped between you and the warmth of the world. This is the weather of a supervolcano's aftermath. Not heat, not lava cold, a strange, aching cold. Not the kind that comes from snow or ice, but a chill born of ash and invisible particles high above the earth. Because when a supervolcano erupts, it doesn't just send molten rock and glass into the sky, it sends gases. Sulfur dioxide, mostly. That sulfur becomes a mirror in the upper atmosphere. This mirror doesn't reflect your face, it reflects sunlight, high in the stratosphere, above the clouds, above the plains. Sulfur dioxide reacts with water vapor to form tiny droplets called sulfate aerosols. These aerosols are like a thin, shimmering curtain around the earth. They scatter sunlight. Some of it bounces away, some makes it through. Okay, but the effect, globally, is cooling. It's called a volcanic winter. And it doesn't start all at once. In the first days after an eruption, the sky fills with ash. It's heavy, it falls quickly, but the sulfur rises. It travels higher, rides winds that cross continents. Okay, in weeks, it circles the planet. And then the cooling begins. Temperatures drop not drastically at first, a few degrees, but over seasons, that difference grows. Summers become shorter, winters bite harder. Monsoon cycles shift, droughts appear in places that were once lush. Floods strike where the soil no longer holds its balance. This has happened before. In 1815, Mount Tambora erupted in Indonesia. It wasn't a supervolcano, but it came close. The next year, 1816, became known as the year without a summer. In Europe and North America, frosts struck in June. Snow fell in July. Crops failed. Famine spread. Even artists noticed skies painted in eerie reds and purples. Sunsets that lasted too long. Colors made surreal by particles in the air. Tam Boar released an estimated 60 megatons of sulfur into the sky. Yellowstone could release more. Scientists use climate models to estimate the global impact of such an event. They simulate a supereruption and watch, virtually, how the clouds move, how the sunlight changes, okay, how temperatures shift. And what they find is this: global temperatures could drop by 3 to 5 degrees Celsius within a year. Cooling might last a decade or more. Precipitation patterns would shift worldwide. Agricultural yields would fall, especially in already vulnerable regions. In short, the climate would change, not forever, but for long enough. And yet, it's not the cold itself that is most dangerous. It's the unpredictability. Crops rely on rhythm. Rain in spring, sun in summer, a gentle slope toward harvest. But volcanic winter breaks that rhythm. The rains come too late, or not at all. The heat arrives in autumn, too late to matter. Or the frost strikes in early May, before life has had its chance to bloom. And it is not only crops. Animals migrate by temperature and light. Insects hatch based on warmth. Coral reefs, already strained by warming seas, can be shocked by sudden cold. Even birds lose their way when the sun's signal grows dim. The world becomes slightly offbeat. And that offbeat hums across every continent. Some places become wetter, as the jet streams shift, others dry out completely. In South Asia, monsoon rains might fail for several years, leading to drought and food crisis. In Africa, the Sahel might shift again, expanding or contracting its grasp. In North America, storms could change their path. Hurricanes could become less frequent or more erratic. No one knows for certain. That's the hardest part. Supervolcanoes are not just explosive, they're mysterious. Every eruption is different, and the atmosphere is not a machine. It's a poem, responsive, variable, complex. So scientists don't make promises, okay? They make models. They simulate. They guess with evidence. But in the end, nature keeps a few secrets. Still, we've seen enough to know the pattern. After Mount Pinatubo erupted in 1991, its global temperatures dropped about 0.6 degrees Celsius for 2 years. That's measurable. It's real. And Pinatubo was small compared to what Yellowstone could do. But just as the cooling is real, so too is the recovery. Sulfate aerosols don't last forever. They settle. They break down. Stratosphere slowly clears. Within a decade, the light returns to normal. Planet EXHLS. And in that return, there is also growth. In the long term, volcanic ash enriches soil. It adds minerals. It rebuilds fertility. Crops eventually return. Forests regrow. The earth finds a new balance. Different, but livable. This is what the weather teaches us. Interruption, followed by restoration. But still, how do we live through the interruption? Imagine a modern world suddenly dimmed. Solar panels generate less electricity. Crops need artificial light. Cities consume more power for heat. Supply chains stretch thin, not because of war or politics, but because of the sky. Food prices rise. Water becomes precious. And even moods shift. Humans feel sunlight on a biological level. Less light means more depression, more fatigue, more uncertainty. And yet, we adapt. In the coldest places on Earth, people have always found ways. Underground storage, communal warmth, foods that last, traditions that teach patience. If a supervolcano creates a long winter, humanity will respond with old instincts: gather, protect, invent. Already, scientists studied the climate responses to previous eruptions. Delicate tree rings each ring a record of sunlight and rain. They analyze ice cores, measuring sulfate levels trapped in frozen bubbles, and they prepare. Some researchers even wonder, could a supervolcano help cool a warming world? Could the particles it sends into the sky balance our emissions? Okay. A dangerous thought, because cooling by force is not precision, it's gamble. And nature rarely lets us control her levers without cost. So instead, we watch, model, we learn. We know that when the next supervolcano speaks, the world will pause. Not in fear, perhaps, but in adjustment. The clouds will drift. The sun will blink. And we will remember that the weather is not only local, it is planetary and ancient, and vulnerable. So the next time you feel the warmth of the sun on your skin, remember this: that warmth has traveled 93 million miles. This is not guaranteed. It has passed through clouds, ozone, and, perhaps, some thin veil of volcanic memory. And if one morning the light feels strange, stay still a moment. Breathe. The earth is still turning. The sky is still open. The weather is simply remembering. Something older than us all. And as the winds settle, as the world reshapes around the silence of a cooled sky, a deeper thought drifts in, soft and unfinished. What if Yellowstone isn't the only one? The earth rarely tells its secrets plainly. You walk through a forest. You see trees, a slope, the hush of pine needles underfoot. Maybe a small valley, a distant ridge, a blue sky above it all. And beneath you, it feels solid, ordinary. There is no reason to suspect anything unusual. The breeze is gentle. The grass moves with it. The birds are busy, but hidden beneath this serenity, the earth may be gathering itself. We speak so often of Yellowstone, its vast caldera, its geysers, its colorful, boiling pools that it begins to feel like the only place of its kind. But it is not. The planet, in its deep time, has left other clues, other scars, other sleeping giants, and some of them are beneath your feet, right? Now, let us begin in California. Tucked into the eastern edge of the Sierra Nevada mountains is the Long Valley Caldera. To a passing traveler, it doesn't shout. The town of Mammoth. Lakes, nearby ski resorts, quiet cabins, winding trails. Tourists come and go, never knowing that beneath their boots is one of the largest calderas in North America. Long Valley erupted around 760,000 years ago. That number feels vast, almost soothing, but the scale of the eruption still speaks. From that blast has been found across the western United States, as far as Nebraska. The caldera it left behind spans 20 miles east to west. It is not a crater you can see from a hilltop. It is a landscape. It holds roads, forests, even towns, and it still breathes. In the 1980s, the ground in Long Valley began to rise. Tear appeared in the middle of the caldera, earth lifting, ever so slightly. Earthquakes followed, swarms of them. Scientists watched carefully, unsure if it was just movement or the start of something more. The unrest eventually slowed. But it reminded us, this place is not finished. Not all supervolcano candidates erupt in obvious places. Some are buried under history, under geography, under assumption. Take the Valles Caldera in New Mexico. Nestled in the Jemez Mountains, it looks more like a meadow than a volcano. Soft ridges curl around a central valley. The grasses are high. The wildflowers bloom in season. Elk move slowly through the early fog. But the land is warm, geothermally active. Hot springs bubble. The earth exhales in faint wisps of steam. Valles last erupted about 1.25 million years ago. That eruption formed a caldera nearly 13 miles wide. It's like Long Valley. It has since filled with life and time. But the scars remain ridges where magma once surged, fractures where pressure sought escape, and the story goes on further north. In Oregon lies the Newberry volcano. It's not as famous as Yellowstone, but its history is rich. Over the past 500,000 years, it has erupted more than 400 times. Today, Newberry is quiet, but inside its broad caldera lie lakes, lava flows, and signs of recent warmth. The U.S. Geological Survey monitors it closely. Then there's Lake Toba, on the island of Sumatra in Indonesia. Toba is not in the U.S., but it must be mentioned, for it is the largest supervolcano eruption known in the past 2 million years. Around 74,000 years ago, Toba erupted so violently that it may have changed human history. Some researchers believe it caused a genetic bottleneck, a dramatic reduction in the global human population due to climate shifts and resource scarcity. The eruption formed a caldera so vast that it is now filled by Lake Toba, itself 62 miles long and nearly 20 miles wide. At its center, a small island rises, Masir, born from a resurgent dome of magma. Even today, geothermal activity persists beneath the lake. But perhaps the most sobering part of this tale is not where these supervolcanoes are, but at how easily they blend in. A caldera is not a peak. It is not a cone. It does not rise to command your attention. It sinks. When a massive eruption empties a magma chamber, the land above it collapses. What remains is often wide, flat, and deceptive. It becomes meadow, basin, high desert. Roads are built. Houses. People forget. You could be standing in a supervolcano and never know. And then there are the hidden ones. Scientists use a combination of tools to find potential caldera systems: seismic tomography, which lets them see beneath the earth by mapping how earthquake waves travel; gravity measurements, which detect anomalous places where the mass of the earth is oddly light, suggesting molten chambers; magnetotelluric imaging, which measures how the earth's crust conducts electrical currents, revealing hot, molten regions. Through these tools, researchers have identified places like the La Guerrilla caldera in Colorado, site of the Fish Canyon tuff eruption, which was once among the largest in Earth's history. Though that system is long dormant, its existence tells us something important. Supervolcanoes are not rare in geological time. They are just slow, and that slowness is deceptive. The ground beneath the caldera may shift by inches per year. Steam may vent quietly from a hillside. A lake may rise by millimeters. These are not events you feel, but they are part of a long conversation, one the Earth has been having with itself for eons. There are likely calderas we haven't found yet. Some may lie beneath the oceans, where volcanic ridges hide in the dark. Others might be beneath glaciers, masked by ice and silence. And still others may sleep in places we never thought to look: beneath plains, beneath deserts, beneath the comfortable rhythm of ordinary life. So what does it mean to live above such a thing? It means awareness, not fear. Geologists classify these systems and study their pasts to estimate what they might do. They look for signs: deformation, gas release, seismic activity, thermal anomalies. They monitor in real time, and while prediction is still difficult, our understanding grows with every year. It also means perspective. The Earth is vast, These systems take hundreds of thousands of years to form, and often just as long to stir. An active caldera is not a ticking clock, it is more like a slowly rising tide, and tides give warnings. If Yellowstone were to erupt tomorrow, it would change the world. But so far, it does not seem to want to, nor do Long Valley, Valleys, or Newberry. But they are watched, because watching is what lets us sleep. You may wonder why they are not more famous, why we don't talk about these other calderas on the news, or teach about them in school. The answer is simple. They are quiet, and in a world full of noise. The quiet things often go unnoticed, but they are there, beneath you, around you, beneath the forests, the ski slopes, the high deserts, and the hiking trails, sleeping, stretching, breathing slowly. And every so often, they remind us: a small quake swarm, a faint bulge, plume of steam from a place that used to be dry. Not threats, just whispers dot the earth, adjusting its weight, clearing its throat, rehearsing its age-old language of fire and stillness. So the next time you stand in a meadow and wonder why the land feels different, rounder, strange in its silence, remember this: the world beneath your feet may have a story far older than the trail you walk, and just beyond that hill, there might be another caldera waiting to be found. You may picture a volcano waking as a loud thing, an explosion, a crack, a roaring curtain of fire rushing up from the earth. But the reality of awakening, especially for a supervolcano, is much quieter. It begins with things that don't look like much. Maybe the land lifts by a centimeter. Maybe a cluster of small earthquakes rattles a canyon, too deep for anyone to feel. Maybe a hot spring becomes a little hotter. Maybe gas just a little rises from a place where there was none before. Maybe the trees on a hillside start to die, their roots warmed from below by something invisible. These are not omens. They are rehearsals that the earth doesn't shout without first clearing its throat. And if you know how to listen, those murmurs speak in patterns. Let's begin with uplift. Across many calderasi Yellowstone, Cala Long, Campi, Flagray, near Naples, the ground sometimes swells, slowly, gradually, like breath held just beneath the skin. Scientists measured this with GPS and satellite radar to compare one day's shape to the next, sometimes seeing the land rise by millimeters, other times by inches. It happens so slowly, you could stand there and feel nothing, but the ground has moved. Why? Because beneath the surface, magma is shifting. It might be rising into a chamber. It might be pressurizing, pushing, stretching the crust just a little. Sometimes it cools again, and the land relaxes. Other times, it continues months, even years, of gentle swelling. Uplift is not a promise of eruption, but it is a sign of change. Then there are earthquakes. Most of the tremors near supervolcanoes are small magnitude, 1 south, 2 south, sometimes 3 south, barely enough to shake a teacup. But when they cluster in swarms hundreds, even thousands, over a few days, they catch attention. Why swarms? 'Cause as magma shifts, it doesn't move smoothly. It forces its way into cracks, finds faults, pushes at brittle rock. That rock breaks sand. The earth shivers in reply. Sometimes these swarms come with no surface change. Other times they accompany uplift or new gas emissions. When several signs align, scientists watch more closely. There is another sign, 2 more, subtle, more spectral. Gas. Volcanoes, even sleeping ones, breathe. They release gases like carbon dioxide CO, sulfur dioxide SO, and hydrogen sulfide H's. Most of this seeps out quietly, carried by vents or hidden in groundwater. But when those gas levels change, when more CO is released, or new vents apparate, can suggest that magma is rising, or decompressing. At Yellowstone, for example, scientists have found places where trees suddenly die in clusters, not from disease or drought, but from carbon dioxide collecting near the roots, suffocating them silently. Even without eruption, the volcano makes itself known. And yet, all of this can still mean nothing, or everything. That's what makes it difficult. Imagine trying to interpret the mood of a being that thinks in centuries. You watch for shifts in breath. You listen for murmurs in sleep. You try to read a story written in heat, pressure, and patience, and still can only guess. One of the most closely watched volcanic systems today is Campi Flegrei, near Naples. Unlike Vesuvius, which rises like a classical mountain, Campi Flegrei is a caldera, flat, subtle, almost invisible, yet it has been swelling on and off for decades. In the 1980s, parts of the town of Pozzuoli had to be evacuated because the ground rose so quickly it cracked buildings. The port lifted out of the sea, but the volcano did not erupt. It simply breathed, and it still does, each year. Scientists watch the data. Are the earthquakes getting shallower? Is the gas changing composition? Is the uplift accelerating? It's a kind of planetary checkup, a medical chart for a system too large to see all at once. And here's something deeper. The signs are often clearest in hindsight. Only after an eruption do we piece together what was trying to be said. Only after the ash falls and the dust settles do we look back and realize, yes, there were signs, just didn't know how to hear them yet. This is not failure, it's learning, because for every volcano that erupts with warning, there are dozens that whisper and return to stillness. They swell, they shake, they warm the land, and then they rest again. The earth is not trying to trick us. It simply moves on a different scale. Its clues are there. They are wrapped in layers of noise, seasonal changes, tectonic activity, weather patterns, even human interference. A satellite glitch can look like uplift. A construction blast can mimic a tremor. And so we watch carefully, not with fear, but with attention, because the signs are cumulative. A single quake, no worry. A swelling bulge over months. A yellow flag, new fumaroles, rising gas, changing chemistry. A louder whisper. It's not about predicting an exact day. It's about reading a trend, knowing when the volcano is shifting from restlessness to preparation. Sometimes, signs come quickly, like at Mount Pinatubo in 1991, when tremors and swelling accelerated rapidly, allowing timely evacuation. Other times, the warnings stretch over decades, giving false starts and slow rhythms. And occasionally, there are no signs at all, only a sudden breach of silence. That is rare, but not impossible, which is why we listen not just to one volcano, but to many. We built networks of sensors, of satellites, of scientists. We compared data from Japan, Italy, Indonesia, the United States. We try to build a language out of magma, and in doing so, we begin to understand not just how eruptions happen, but how the planet lives, because the Earth is alive, not in the way animals are, but in its own deep way. It moves, it breathes, it grows. Volcanoes are not mistakes in that system. They are expressions, and their signs, though subtle, gentle, sometimes invisible cues are not warnings of wrath. They are part of the song. A note here, a tremor there, a rising steam, like a sigh between verses. And so, you sleep beneath this quiet music. You walk above it, drive across it, breathe in the air warmed by it. You are not separate from it. You are folded into the rhythm, and whether or not you feel it, the Earth is always rehearsing something, a shift, a silence, a sound still waiting to be heard. The next chapter begins when we ask how we measured that rehearsal in human time, 'cause while the Earth thinks in magma, we think in clocks. You live by time. You wake when the clock tells you. You measure your life in birthdays, appointments, and sunrises. But the Earth does not keep time the way you do. Its clock is different. Its numbers are not measured in hours or days, but in cooling magma, shifting plates, growing mountains, and disappearing seas. And this difference matters, because when we speak of supervolcanoes, of eruptions so vast they could change weather, move species, redraw maps, we are speaking of things that do not fit inside human calendars. You count in decades. The volcano counts in millennia. Still, you try to make sense of it. Imagine a chamber of magma deep beneath the soil. It is not a boiling lake, not a pool of fire waiting to burst. It is slow, viscous, heavy. It grows not with speed, but with the pressure of centuries. A few cubic meters of molten rock might enter the chamber in a year. Barely a breath. A few thousand years later, the chamber has grown. But does it erupt? Not necessarily. It may cool, may shift, may wait. That is its time, and we must learn to read it. So, we build tools. We place GPS receivers on the ground and measure uplift. We bury seismometers to feel the Earth twitch, sample gas, and compare its chemistry over decades. We build models of chambers, flows, temperatures, all in the hope of predicting something that moves slower than our imagination. And yet, our language stumbles. We say soon, but to a supervolcano, soon might mean in 5,000 years. We say, not in our lifetime, but the Earth does not promise such things. It has erupted before. It will erupt again. Can't, in between, it will wait with the patience of stone. Yellowstone last erupted 640,000 years ago. Before that, around 1.3 million years. Before that, 2.1 million years. These are not regular intervals. They are not reliable patterns. They are echoes in a long, quiet song. And so humanity watches, not in panic, not in paralysis, but in partnership, because living on this planet means accepting the deep rhythms that shaped it. The magma beneath Yellowstone moves slowly, but we don't need speed to study change, okay? A slow clock can still be read if you're willing to be still with it. This is the tension. We want answers, fast. We want to know if Yellowstone will erupt in 2035 or 2145 or never. But the Earth does not respond to forecasts. It responds to forces. And so we must adjust. We build histories from rock layers. We read ash beds like scrolls. We drill deep cores and sample the gases caught in ice, trying to reconstruct the long breath of time. It is not prediction. It is pattern. It is not certainty. It is story. Each eruption leaves a trace, a layer of ash, a shifted crust, a silence. These traces become our map. Maps can help us prepare. Imagine this. A child born today may live 100 years. In that span, Yellowstone may do nothing. It may rumble. It may swell. It may rest. But across 1,000 lifetimes, something will change. The chamber will grow. The crust may thin. And one day, long after our cities have turned to dust, it will erupt again. Does that make it less important? No, because even slow clocks must be respected. And because preparing for the rare does not mean fearing it. It means honoring it. To build for what might happen in 500 years is not wasteful. It is an act of kinship with the future. And so, we teach. We tell students about calderas, about magma chambers, about ashfall. We model scenarios, not to scare, but to understand. A major eruption might ground plains, choke crops, cool the earth for years. But it would not be the end. It will be a season, and we have seen such seasons before. The eruption of Toba in Indonesia around 74,000 years ago may have triggered a global cooling. It may have altered migration patterns, shaped human evolution, left echoes in myth. And yet, life went on, because life is stubborn. It adjusts, it returns, listens to the long clock, and finds a way. So, you live with 2 time scales. There is the time of your breath, the time of your heart, the time of your plans and dreams. And there is the time of magma, of shifting plates, of continents breaking and colliding. You walk on both. Every step you take rests on stone shaped by millions of years. And though you may never feel it shift, it is always shifting, quietly, patiently, with a clock too large to hear. And maybe that's the lesson: to prepare without panic, to study without fear, to live fully, even knowing the ground may one day move. The earth is not cruel. It is simply old. And age does not mean anger. It means presence. So you rest tonight on a living world. A world that keeps time, not in minutes, but in magma. And though its clock may seem silent, it is ticking, just very, very slowly. The next chapter asks, if the earth moves at such a deep pace, can we ever truly predict when its silence will end? You live in a world of forecasts. You check the weather, ask the internet what tomorrow looks like. Watch satellites track storms across oceans as if they were drifting thoughts. You expect to know before the rain begins, before the storm arrives, before the sky changes its mind. But beneath your feet, a different kind of storm is forming, one that doesn't fit into forecasts. You cannot check an app to see when a supervolcano might wake. And yet, we try, because humans are pattern seekers. We look at tea leaves, stock charts, migratory birds, and try to guess what's next. It is in your nature to look ahead. And so, you ask the question, can we predict the next supervolcano eruption? Let's begin by stepping into the scientist's shoes. Not lab coats and glass beakers, but hard hats, boots, and deep patience. These scientists listen, not with ears, but with machines. They plant seismometers in the soil, tiny devices that feel vibrations we could never notice with skin or bones. They track tremors, earthquakes too soft for cities to feel. It's the kind of tiny movements that might signal magma shifting deep below. And sometimes the earth begins to murmur, a pulse here, a cough there, but it doesn't speak in complete sentences. Some bulges in the ground come and go. Some gas plumes mean everything or nothing. Some earthquakes whisper warning. Others just stretch and yawn. The earth, it turns out, is not as straightforward. Storyteller. And so, prediction is not a declaration. It's a practice of listening with humility. At Yellowstone, for example, the ground rises and falls like a breath. In some decades, it rises by inches. In others, it settles against quietly, without consequence. Does that mean an eruption is near? Or is the caldera simply adjusting, releasing pressure and size, not screams? We don't know, not yet. And that uncertainty can feel uncomfortable, because in modern life, uncertainty is often mistaken for failure. You want yes or no, soon or never. But the Earth offers only maybe. Still, let's look at what we can know. There are warning signs. You pay attention. If a supervolcano like Yellowstone were about to erupt, scientists believe we would see a dramatic rise in earthquakes. Not just one or two, but swarms of shaking across days or weeks. A sudden and sustained bulging of the ground, measurable by satellites watching from the quiet of space. A change in gas emissions, particularly sulfur dioxide, released from cracks and vents as pressure builds below. A rise in surface temperature, perhaps subtle, but enough to signal the magma is stirring. These signs would not go unnoticed. They would trigger alerts, models, discussions, teams of scientists huddling around maps, data streams, simulations. But would that be enough time to prepare? That's the second question. Prediction is not just about if, but when. If Yellowstone gave us a few weeks warning, would that be enough? Would we evacuate the region? Ground flights, cover crops with plastic, stock warehouses with masks and water. Would governments coordinate or hesitate? This is why prediction alone is not enough. You also need trust, communication, planning. You need to believe the scientists, okay? And the scientists need to be sure enough to speak clearly. And that is the hardest part, because nature does not give clear signals. It gives maybes. And humans are not always good with maybes. Now, imagine the scientists again. They have years of training, dozens of instruments, access to computer models that run through thousands of scenarios every day. But even they will tell you there is no certainty. No eruption in recorded history has been perfectly predicted. Some volcanoes rumble for months, then fall silent. Others wake without warning. We are still learning the language of Earth's breath. Still, that doesn't mean we are helpless. Prediction may not be perfect, but preparation is powerful, because while we may not know exactly when a supervolcano will erupt, we can still imagine what would happen if it did, and from that imagining, we can build plans, evacuation routes, food reserves, filtration systems, international agreements on trade and aid. These aren't guesses, they're readiness. Of them like umbrellas. You don't open one every day, but it's wise to carry one when the clouds gather. And so, humanity carries quiet umbrellas for volcanoes, not because we live in fear, but because we live in awareness. Still, the question lingers. What if we miss the signs? What if the ground swells and we don't notice? What if the gases rise and we misread the meaning? This is the reality of science at the edge of knowledge, at the edge of power, at the edge of patience. Because sometimes the earth changes faster than we expect, but sometimes it gives us time. And in that time, we build understanding. We drill into ancient ash layers. We model magma chambers with 3D simulations. We collaborate across borders, across disciplines, across generations. Every new study, every new sample, adds one more word to our fragile dictionary of volcanic language. And maybe, someday, the dictionary will be rich enough to give us the answers we seek. But even then, we must remember, the earth owes us nothing. It does not speak in human terms. It does not erupt for our schedules. It is not malicious. It is not generous. It simply is. And in that is both the beauty and the challenge to live on a planet that breathes fire, and yet still dares to dream, to build, to rest. You walk through a world layered in ash and memory. Every field, every city, every shoreline, once buried beneath dust or born from flame. And still, we remain. Still, we ask. Still, we wonder. Not because we will always find answers, but because the act of asking connects us to the earth itself. So tonight, you rest with the uncertainty. You let it be soft, not frightening. You let it breathe beside you like an old, powerful animal, not threatening, okay, but alive. Because maybe prediction is not the goal. Maybe presence is. Maybe listening is enough. And in the quiet, in the stillness, you find a strange peace in not knowing. The next chapter begins with a question not of science, but of consequence. What if it happened tomorrow? Would we notice in time? Or would the sky simply begin to change? You wake up to quiet. The morning is slow and gray. The air carries a stillness you can't quite place. It isn't panic, it's absence. Something missing from the usual hum of life. No birdsong, no airplanes, no sun. At first, it feels like a dream. The light outside is strange, dim, and silvered, as if the world has stepped behind a curtain. Clouds hang low, but they don't move. The sky is thick, but not with rain. Then you check your phone. No signal. Not just one bar, no bars at all. Wi-Fi isn't working. The apps won't refresh. The digital world has gone quiet. It takes hours for word to spread, not through breaking news, but through old-fashioned voices, neighbors talking on porches, a radio that still works if you crank it by hand. Someone remembers they have a shortwave. Someone else saw something online before it went dark. A word passes from mouth to mouth, eruption, Yellowstone. It wasn't supposed to happen. Not yet. Not so soon. But it did. And now the sky is changing. It didn't explode like in the movies. No mushroom cloud. No screaming. No flames chasing cars down highways. It began with pressurizing deep in the earth. Then the ground cracked open and ash began to flow like breath through a wound. It's still erupting, still rising, and the ash is coming your way. At first, you'd think of it as dust, a faint powder in the air, like flour spilled from some enormous cupboard. But this dust is heavier, stranger. It gathers on window panes, grits between your teeth. It muffles sound, smells like sulfur and stone, and it doesn't stop. By the end of the first day, cars are coated in gray. By the second, roads are slick and strange. By the third, visibility drops to just a few feet. The sun becomes a pale disk, as if trying to shine through wet paper. And now the world begins to pause. Airports shut down. You can't fly through ash, it clogs engines, blinds, pilots. Trains slow, then stop. Buses vanish from their routes. People stay indoors, sealing windows with towels, taping doors shut. Not from fear, at least, not yet, but from grit. Because breathing is harder now. Ash scratches the throat. It clings to the soft parts of your lungs. The hospitals are full, not with injuries, but with irritation. Masks become sacred. Water becomes sacred. Information becomes sacred. The internet stutters, then fails completely. Tirades falter not. Everywhere, not at once, but enough to change everything. The ash falls like snow. But it doesn't melt. It builds. It collapses roofs. It buries crops. Sneaks into the corners of homes. And slowly, the world understands. This is not a day-long event. This is not a weekend storm. This is something else entirely. This is a pause. A long one. Governments call it an interruption. Not a catastrophe. Not the end of the world. But something between. Flights are grounded indefinitely. Supply chains fracture. Food distribution slows. People ration. They whisper. Hey. Some regions are hit harder than others. Those closest to the eruption. The American West see black skies for weeks. Ash piles in feet, not inches. The power lines collapse beneath its weight. Farther out, the effects are subtle but eerie. Ash in the rainwater. Animals acting strangely. A drop in global temperature, just a few degrees. But a few degrees is enough. Enough to shorten growing seasons. It's enough to push fragile ecosystems into retreat. It's enough to send certain crops into dormancy. And this, too, spreads quietly. You feel it in your body, in the way your fingers ache, in the way you shiver, even indoors, in the way the light doesn't quite return. By now, it's clear. The supervolcano didn't end the world. It interrupted it, and it will take time to restart. You learn new rhythms. You wake with the sun, because electricity is inconsistent. You cook simpler meals. You talk more really talk, because there's nothing else to do. Screens are blank. The world is quieter, and strangely, in that quiet, there is peace, because there's no rush now, no commute, no deadlines, only the slow, a shared experience of waiting and healing. You start to measure days by the shape of the light, by the way the ash moves when the wind returns, by the tone of the radio when it speaks at all. Governments shift focus from control to care. Distribution becomes local. Barter returns. Neighbors become necessary again. You trade lentils for batteries. You give rice in exchange for medicine. You share stories like firewood, and slowly a new kind of normal forms. Ash is still in the air, but it becomes part of the background. The human body, resilient as always, adapts. Masks are worn without question. People move more slowly, conserving breath. Children play indoors, inventing ash-free games. Life does not stop. It just changes shape. And scientists always watching begin to speak again. They say the worst is over. The eruption is slowing. The skies will clear. Not soon, but eventually. And when it does, the rebuilding will begin. Some roads will never reopen. Some cities will shrink. Some crops will vanish forever. But others will thrive in the strange new soil. Plants that love ash. Mushrooms that feast on ruin. People who grow strong and quiet. The eruption becomes a before and after. A line in history's book, and one day it becomes story. It's told by candlelight, whispered across generations. Do you remember when the sky turned gray? Do you remember the winter that came in summer? You don't forget, but you don't fear it anymore, because you lived through the pause. You felt the earth breathe out slow and wide, and you waited gently for the breath to return. So now, when you hear the word supervolcano, you don't flinch. You listen, you remember, and you wonder, quietly, what would the world look like if it had never been interrupted? What would we have missed if we never learned to pause? In the next chapter, we step into that silence, into the strange months and years that followed the fall, when the world, still dusted in ash, begins the slow work of healing. After the breathless surge, after the roaring stops, the world falls still. The clouds that once curled upward in fury now drift heavy with ash. Gray smothers green, and the horizon becomes a quiet smear between land and sky. Everything rests blanketed, not by peace, but by the slow unfolding of aftermath. This is what comes after the supervolcano size. It does not heal with urgency. It does not spring back with sudden color. The healing of Earth happens in glacial inches. It is not like a wound on skin, where new cells knit a scab overnight. No, this healing is the kind that forgets time completely. It does not hurry. It does not remember what it was before. It simply begins. Beneath the ash, seeds remain. Not all of them survive. Some are crushed, some are scorched, but others, lucky or stubborn or sheltered by chance, bide their time. For months, maybe years, they lie dormant in a world that feels paused. But they are not dead. They are memory waiting to bloom. Ash, too, has its role in rebirth. Though it chokes at first, suffocating leaves and coating streams, it will one day become soil. Rich soil, in fact, full of minerals that plants quietly crave. Phosphorus, potassium, calcium. It is Earth's strange recipe for fertility. Burn, break, bury, then grow. You would not notice this in a day, or a week, or a season, but wait long enough, and green returns. It comes not with fanfare, but with moss, a soft fuzz over broken stone. Then lichens, clinging to ash-covered bark. Then graston, determined blades slicing upward through silence. Each leaf is a declaration. We are still here. Life does not forget. Animals return too, in time. First, the insects, tiny and resilient, finding warmth in cracks and moisture beneath decay. Then the birds, cautious, hungry, testing the air. Then rodents and deer, and even the larger wanderers who sniff and settle, sensing that food has begun to grow again. But the forests do not reappear all at once. They rebuild branch by branch, root by reaching root. Some trees never return. Others, unexpected ones, take their place: pine instead of oak, fern instead of flower. The ecology reshapes itself like a scar that decides to blossom instead of smooth over. It remembers the wound, but it does not try to become what it was. It evolves. Rivers may have changed their path by then. Lakes may have shifted in their beds. Some will have dried under the sun that finally returned after months of ash-dammed light. Others may have formed anew in the bowls left behind by collapsing rock. Where once there was magma, now there is water, cold, clear, reflecting a sky that seems innocent again, but innocence is not what the land holds. It holds memory. Layers of it compressed beneath your feet. If you were to dig into that soil 1,000 years later, you'd find bands of color, light and dark, life and death. A geologist might name them the eruption layer, the ashfall horizon, the regrowth, strata, but to the earth, they are not labels. They are just the story it tells in rings and dust and stone. Humans, too, leave traces. The ruins of towns abandoned in ash. Fences half swallowed by new grass. Roads that end in nothing. And sometimes new settlements that rise right beside the old, built with different knowledge, different hopes. Built with memory, not denial. Because healing is not forgetting. It is adapting. It's carrying the bruise and walking forward anyway. In places like Mount Tambora, where a supervolcano reshaped the 19th century sky, you can now find rich green hillsides and towns bustling at the edges. Life returned. People farm again on land once thought cursed. Children play where once the ash was knee-deep, and in Yellowstone, where no supervolcano has yet reawakened. But might there are clues of ancient healing, trees that grow over collapsed vents, hot springs that shifted after past tremors, soil enriched by the breath of past fire. The land remembers, and yet it does not live in fear. That is a lesson we might take from it. Healing for Earth is a cycle. It is not linear. It does not end. There is no perfect form to return to. There is only change in the quiet rhythm of recovery. Sometimes, in our human scale of time, we want answers fast. We want the sky to clear, the ash to vanish, the crops to grow on schedule. But the earth does not know our schedules. It knows seasons measured in centuries. It rebuilds ecosystems the way a glacier sculpts valleys with patience, with persistence, with grace. In the wake of destruction, there is always space for life to reinvent itself. Space for silence to teach us what we took for granted. Space for a new kind of resilience, one that grows out of the blackened soil and says, I am not the same, but I am still here. And you, in your own way, are part of that rhythm. You breathe the dust of ancient eruptions. You eat the food that grows from volcanic soils. You walk on lands once seared, now softened by time. The history of supervolcanoes is not just in textbooks, it is under your feet. It's in your lungs, in your memory. So, when you think of healing, do not imagine perfection. Imagine process. Imagine a landscape learning to be whole in a different way. There are still places in the world, peeling from eruptions long past. The scars are visible from space giant calderas, reshaped valleys, lakes where craters once roared. But even there, life has not retreated. It has adjusted, bent, blossomed. You could see it in Iceland, where lava plains now host meadows. You could see it in Indonesia, where rice paddies ripple over old ash beds. You can see it in you how your body, like the earth, can hurt and pause and begin again. Because healing does not mean going back. It means moving forward with what remains. It means trusting that the soil will soften, that green will return, that breath, once caught in fear, will find its rhythm again, and slowly, it does, even in the quietest moments, when the sky is still pale with memory and the land seems frozen and ash-tiny roots are reaching downward, tiny shoots are reaching up. The earth, ever ancient, always begins again, and as you lie here, eyes heavy, thoughts quiet, remember, somewhere, beneath the ash of yesterday's fire, a seed is stirring, a leaf is waiting, a forest is already whispering its return, and just beneath that, something else breathes slowly, deeply, patiently, ready, because even as we heal, we listen, and the earth still speaks. You live in a world of patterns. The rhythm of the seasons, the tilt of the sun, the quiet falling of rain in spring. The earth, beneath all its change and mystery, still hums with recurring truths. In preparation, true, thoughtful preparation begins, not with panic, but with paying attention to those truths. Supervolcanoes do not arrive like thunderclaps. They do not break through the crust without a whisper of warning. Instead, they prepare their own stage slowly, over centuries. The land lifts, trembles, breathes more heat than usual. Geysers grow restless. Water boils faster. Ground rises, ever so slightly. These are not shouts. They are murmurs. And if we are listening, they are enough. So the question is not will it happen, but when and how do we live, knowing it might? Panic is sharp and sudden, blinds, deafens, rushes in without thought. But the earth does not panic. Neither should we. To prepare without panic is to choose presence over fear. It is to recognize the power of the planet and still live gently upon it, okay? It is to see the volcano sleeping and to build your home, not to close. It is to understand the ash and plant crops that can endure it. It is to respect the timeline of magma, which might stretch far beyond a human life. Still take it seriously. Scientists do this every day, in quiet rooms filled with seismographs and thermal maps. Volcanologists monitor the slow, shifting breath of the earth. They watch heat signatures from space, compare tremor patterns, sample gas from steaming vents. They don't wait for smoke, okay? They look for silence that's changing shape. And still, they do not claim certainty, because volcanoes, especially the super ones, do not follow schedules. They do not answer questions, okay? They shift, they build, they wait. And that uncertainty is not a failure of science. It is the nature of the deep earth. So how do you prepare for something that may not happen in your lifetime? The answer lies in stories, in memories, in passing down the knowledge that such things are possible. Children in Japan know how to duck under desks for earthquakes. Families in hurricane zones know which supplies to keep stocked. And in places like Yellowstone, Long Valley, Tapo, and Tobo, where the land remembers ancient fire residents, are learning the quiet language of readiness, not with sirens, but with subtle wisdom. To prepare is to build maps and evacuation routes, even if they're never used. It is to teach geology in schools, not just history. It is to invest in global monitoring systems, because magma doesn't care about borders. It is to keep backup seeds, backup plans, backup power, not from fear, but from reverence. Because preparation is a form of respect. It says, I see you, Earth. I know you are powerful, okay? And I choose to walk alongside that power, not against it. For individuals, it might mean something simpler. Keeping masks that filter ash, having clean water stored, knowing where to go if the sky turns gray, understanding that food chains, power grids, power may falter, but human resilience is strong because we've done this before. When Mount Tambora erupted in 1815, the world felt it. Crops failed, snow fell in June, but people adapted. They shared what they had. Artists painted haunting skies. Farmers learned new methods. Life did not end, it shifted. When Mount Pinatubo erupted in 1991, satellite technology gave us warning. Lives were saved. Ash clouds were tracked. The global temperature dipped briefly, but then rose again. Science helped. So did memory, and should another supervolcano speak, we will respond not with perfection, but with perseverance. Governments plan, emergency services train, geologists model eruption scenarios, track ash paths, simulate global cooling. The knowledge is not secret, it is shared, taught, revised. In this way, preparation becomes a kind of storytelling, a promise whispered across generations. We have been through fire. We have seen the sky darken. But we are still here. Even global efforts have emerged. Volcanic ash advisory centers coordinate between continents. Climate models consider the impact of massive eruptions. International databases track every bulge, quake, and steam vent in sleeping calderas. And above all, the message remains the same. Not if, but when. So, how do you live with that knowledge? You breathe, you watch the sky, you walk the trails of Yellowstone, not with dread, but with awe. You understand that the same planet that can erupt with unimaginable force also gives you forests, oceans, food, and breath. That balance, that duality, is not a reason for fear, but for gratitude. You do not need to carry the burden of prediction, but you can choose awareness. You can learn about the science. You can teach others not to dismiss tremors, not to silence scientists, not to build too close to sleeping giants, because part of preparation is simply not forgetting. You may never see a supervolcano erupt, or you might. About your preparation, your calm acknowledgement that the earth has its own pace can ripple forward into others, just as ancient eruptions left ash in the ice cores. Your quiet readiness becomes a layer of memory for the future, and there is comfort in that, because humans are good at adapting. We have crossed ice ages, survived droughts, rebuilt after fire. What matters is not that we eliminate all risk, but that we understand it, face it, and plan with kindness. Preparedness is not hoarding. It's not fear-mongering. It's not locking yourself away. It's keeping an extra blanket. It's keeping extra rice, knowing who to call. It's listening when the mountain speaks in tremors, and not brushing it off. It's making room for possibility, without letting it consume your peace. And that peace, that steady heartbeat beneath the preparation, is the most important thing. For just like the earth, you are not made for panic. You are made for presence. So sleep, knowing that people are watching, listening, studying, that your home sits upon an old and breathing world, and still, you have made a life here. The earth turns, the magma waits, and the wind continues to whisper through trees that grow from volcanic soil. This is not a story of doom. It is a story of attention, of reverence, living with deep awareness of what lies below, and still choosing to plant, to love, to prepare. And as you lie here, listening to the hush between heartbeats, remember, even a giant, even a supervolcano, begins and ends with silence. And the more you listen, the more you notice what matters. Somewhere deep below your feet, the earth breathes, but tonight it sleeps, and tomorrow you wake, softly, wisely, ready. You lay still now, but the world under you is never truly still. Beneath the layers of soil, under stone and sediment, below aquifers and roots and rock, there is motion, slow motion, patient motion, the kind that does not need to be seen to be felt, the kind that does not need to announce itself. The earth breathes. It breathes with plates that drift like great floating icebergs on a molten sea. It breathes with pockets of gas that hiss in silence, far from ears. It breathes with magma that pools, stretches, thickens, and waits. This is not breath you feel on your skin, but breath you know with something older than thought, something ancestral, something built into the bones of every living thing that's walked across this planet's crust. This is not a bedtime story about monsters. The volcano beneath your feet is not evil. It is not angry. It is not waiting to punish. It is simply a body part of Earth's body resting in cycles too large for human eyes. You see, volcanoes are not accidents. They are conversations between the hot inside and the cool outside, between pressure and patience. They are valves. They're expressions. They're how the earth speaks in deep time and supervolcanoes. They are just a longer breath, not more dangerous, not more angry, just older, more deliberate, more massive. To call them super is not to make them superheroes or villains. It is to recognize scale. When they breathe out, they breathe wide. When they exhale, the air dims, the sun dims, but always, always, the earth continues. It's important to understand this. Earth has no grudge against humanity. Supervolcanoes do not target. They do not scheme. They are not meteors hurtling from nowhere. They are part of this planet's body, moving in rhythms that were ancient long before humans appeared. And if one of them breathes tomorrow, it will not be the end. It will be an unfolding. Yes, the sky may darken, ash may fall, crops may suffer, flights may pause, but people will adapt. They always have. In Iceland, in Indonesia, in Italy, they have learned to farm on cooled lava, to drink from volcanic springs, to grow grapes in ash-rich soil. After all, volcanoes don't just destroy, they build. The most fertile lands in the world sit atop volcanic beds. The valleys that feed millions once smoldered. The cliffs that hold temples and towns were born of fire. Even the air you breathe carries atoms once pushed skyward by ancient eruptions. You are not separate from this process. Entire. You are part of it, part of the long breath of Earth. Imagine the world in deep time, not the calendar in your kitchen. It's not the digital clock glowing by your bed, but time as Earth knows it, slow, circular, measured in layers of stone and glacier, in the drift of continents, in the whisper of tectonic plates rubbing together like old bones. In that kind of time, a supervolcano is not a horror. It is a punctuation mark, a pause, a necessary exhale, and you. You are a brief note in this ongoing song, but you are here. You get to witness it. You get to live on the skin of a living world right now. As you lie still, Yellowstone sleeps. Does Tabo? So does Taba. They rest beneath forests and lakes and tourist trails. People take photos above them, ride horses, boil eggs in geysers. Life continues, even on the thinnest crust. And sometimes, knowing what lies below makes that life even more sacred. Imagine standing above a caldera, the remnants of 1,000-year-old exhale, and realizing that your breath, right now, continues where millions of others once stopped. Imagine the silence that follows a great eruption. It's a hush of ash falling like snow. It's a deep breath the planet takes as it cools, resets, and begins again. You're part of that cycle. It's the trees that grow from old lava. It's the rivers that carve new paths after each eruption. The animals that returned. The seeds that cracked through soot. Even humanity's stories reflect this resilience. After Tambra, there was darkness, but also art. Mary Shelley's Frankenstein was born in a cold, ash-dimmed summer. Painters